They're the big ones that sit on the floor. That if you roll the LTQ out, you'll see a series of pumps there. Okay, these are vacuum pumps. They're low vacuum. Okay, they only get down to about 1,000th of atmospheric pressure, and they're oil filled. Okay, you want to change the pump oil either once a year. It's perfectly fine. You could even do once every 6 months. But the thing is, with the nano spray, you're putting very little material into them. Once a year change is fine.
Question on this. So periodically, like, we see maybe ions aren't getting transferred efficiently. Well, I was told by Bob you could just squirt a little methanol into that ion transfer tube. Is that bad or?
That's perfectly fine.
But how does that affect? Doesn't that end up?
The organic does not dissolve into the oil. The organic comes in, is pumped right out. Water dissolves into the oil and gets stuck. Okay.
So you would suggest not to squirt it with water?
Yeah, don't squirt with water. Squirt with methanol.
We should change
or isopropanol. Now, if you got salt buildup, now the key is what you're building up. If you're organic build, you can do the squirt. Okay. What I actually do is if you're getting a lot of buildup, I'd remove the ion transfer tube and clean it offline. Okay. And if the buildup is whitish, which is probably more salt, I would take that offline and soak it in, run water through. Because the problem is the salt does not, the squirt seems to work with organic material. The salt, squirting water through the front end doesn't get the salt. The problem is the damn salt moves about 1/4 inch and re-dries. So unless you shove a good, 200 mils through there, you're not going to get the salt out of the tube. You're just going to move it down further. So I would say if you're getting salt buildup, pull the tube out and give it a clean. Okay. I have a lab one lab in San Diego is doing pretty well, has 3 ion transfer tubes. They change the transfer tube every single week. Put a new tube in on Monday, and then clean the other 2 tubes during the week when they get a break. Okay.
But they're doing standard. This is Yates, but they're doing standard spray. Are they doing nano spray?
Nano spray.
They are.
Yeah. So one of my guys in San Diego was doing nano spray, and they're just finding that, but they weren't doing, you have the second cleanup. They were doing their salt into the system with the 2D.
So they don't divert the salt wash. It goes right up the tip.
Yeah. Okay. Turbo pumps. You have 3. You have 1 in the LTQ, and then you have 2 on the left side of the FT. Okay. They have a turbo pump pad within them, which is pre-wetted with oil. You want to change that pad once a year. Okay. If you've done that in the past, you can do it yourself. If not, you might want to have an engineer do it. Okay. On the Pfeiffers, it's real simple. You just unscrew it. The biggest problem, you need to find something that actually fits into this hole. It looks like you're going to put a quarter in there, but you really need almost like a $1-sized coin. Okay. Don't do a credit card, which I've used on past and usually break my credit cards in half. Okay. Just basically jet and get you down to better vacuum. Keep this on there.
I mean, I'm a little concerned because we did wash it with water because of our ignorance.
I wouldn't worry about it.
Because we just killed a vacuum pump on our speed map.
Did you rust it out or? Yeah. One comment I want to make is ballasting your pumps. Okay. There is a knob on top to ballast, and that drives the water off. Okay. What it does is you open up the pump. It's not breaking vacuum. It's still pumping. It pumps water in. It pumps air into the back end, and heats the oil up, and drives off the water. Okay. I have a serious problem in that I'm one of these kinds of people. If I go to the store for eggs, I usually come back with a toy for the kids and no eggs. Okay. If you're like me, don't ballast your pump, because my problem is I open it up, I ballast it, and I forget about it, and I end up killing the pump. Okay, so if you're going to ballast, you got to ballast about an hour.
Say again, what is ballast?
There's a little knob on top you open up. Okay, it pumps air into the pump, heats up the oil, and drives off the water. Okay.
So typically, the oil is not being heated up?
No, the oil stays fairly.
Just
the oil's maybe 80, 90 degrees. It's warm, but it's not. This will get it up to 250, 300 degrees. Yeah, and really drive off the water.
C, right?
Not C. Okay, and really drive off the water. Okay, I don't think what I would do is, if you're having vacuum problems, look at it. If you're not having vacuum problems, don't screw with the vacuum system. Okay? Okay. That's one of my big beliefs. Okay, trap and irons. So what we're going to do is we're going to cover how the LTQ works first, and then we'll take the FT and add on. Okay. So if we take out the trap, okay, he's about that long. Okay. He's a quadrupole that's cut into 3 pieces. So you have 4 hyperbolic rods that are cut into 3 pieces for 12 sections total. Okay. We have the front 4 pieces, the front section, we have the back section 4 pieces, and we have the center section, which is about twice as long as the end sections. Okay. The only difference among the rods is the Y rods, which are the vertical rods, versus the X. The X has a slit cut down the left and right side. Okay. Because we cut a slit down the left and right side, we create a field distortion, and we have to take the X rods and we pull them out 0.76 millimeters, and that gets rid of the slit effect. Okay? Make sense?
That's the width. This X0 is...
That's the distance between the 2 rods. So from here to here is 4.76 millimeters, and from here to here is 4 millimeters.
The slit you're detecting through that.
Right. The slits is where the ions are coming out. Okay?
Bigger space.
Now, if we look, we take an X rod, you can see the slit. We combine it with a Y rod, that makes half a trap. We put 2 trap halves together, and we put these little plastic end pieces on to hold the thing together.
So is that just a solid chunk of metal, or
these pieces?
the rods?
Yeah, they're just solid chunk of metal. The interesting thing about the linear trap is it was not a scientific marvel. We knew how to do these things years ago. The problem was we couldn't make the stupid trap symmetrically. Okay, so
It's just a manufacturing.
it was a manufacturing concept. Okay, and to this day we can't make them in the U.S. at all. They're made over by a little bunch of old guys called Vactech over in Germany. Okay.
So the X and so everything is one piece of metal, or each rod is a...
Each segment is a piece. So there's 3 pieces.
That sticks in this encasing.
Right. And the whole key to the trap is not the metal. The key to the trap is this stupid little piece of plastic right here. Okay, that was our big invention about 6 years ago, is we developed a piece of plastic that expands and contracts 3-dimensionally. Okay.
Control that.
And so what happens is when your lab changes humidity and temperature, the trap expands and contracts 3-dimensionally, and the rods stay in the same position. Okay. So
it's just transparent to the user.
Yep, totally transparent to the user. Okay.
What's the slit effect you said something about?
Well, when we cut a slit in the rods, we actually change the shape of the rod. Okay, because now it's not a perfect hyperbolic, it's a hyperbolic, and if you look at the type of the hyperbola where the slit is, it's actually flat. Okay, flat at the 0.05 millimeter level. Okay, it's a fairly little distortion, but it's enough distortion to screw the trap up. And we can get rid of that distortion by taking the X rods and just separating them a bit. Okay, slit effect. Cool, makes sense? Okay, none of that stuff you have to worry about. As long as your trap passes calibration, it's in good shape. If it doesn't pass calibration, for a few obvious reasons that we know about, you're screwed and it goes back to the factory. We can't field fix these ion traps. Okay, the LCQ was a piece of cake. That thing went together. Any idiot could put it together and take it apart. The LTQ is very precision. If the parallelativity or the skew is off by even 0.1 millimeters, the trap will not function.
So what would cause
The engineers take it out to clean it. Okay, we don't allow engineers to touch your trap. Okay, you'll never see an engineer who knows what they're doing on the back end of your trap touching anything. Okay.
Probably most things are removed before ions get into the trap. So it's not
most of that crap, what we find is the stack, okay, catches 99% of it. The next 1% is caught by the Q00. So in a really bad cleaning, your engineer might go back to Q00. Okay, I would only clean the stack. I don't clean Q00 just because there's a good chance of screwing it up. Okay, that's an expensive set of rods to rejig. Okay, we'll go through that during maintenance. Okay, now The ions come into the trap, okay? We got to capture them in 3 dimensions, okay? We got the z dimension, which is the dimension they're being injected, and if they're ejected the ft, that's the z dimension. Horizontal is x dimension and vertical is y dimension, okay? So the first dimension we're going to trap in is the z. So the ions come in